Alright, today we're going to be talking about area. First off, let me tell you that the camera is going to be pretty shaky and it's not going to be that great of quality, but I'm going to try my best to give you everything. The reason why is because our cameraman is not available for the next videos over coming till the end, and I have to do it with my left hand, and I'm right-handed, and this camera is meant for right-handed people. Hopefully you can just stick with me. So when I say area, I don't mean the area of a square or the area of a triangle. What we're talking about here is graphs. Simple graphs. And maybe if we've got this graph right here, whatever, we want to know the area between from 1 to 4. We want to know the area between this and the x-line and what that area is. And you're probably thinking to yourself, why does this even matter? Well, if you have a related rates problem, if you have a problem where you're trying to figure out how much water goes into a tank at this equation, blah, 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 how much water has gone in from 0 to 4 seconds, you use this area to figure out how much water has gone in. You can't just plug in 4 because that's just the amount of water going in at that time. So another thing you can use this for is if you have the derivative, you can use this to figure out from 0 to whatever number at what that number equals at that point. So if I took this, I wanted to know from 0 to 4, and this is the derivative of something, 0 to 4, whatever the answer is, that's what the 4 is at, on the x-axis for x4, whatever the answer is. So how do you go about in doing such a thing? Well, since we're in integrals, we're still going to be using our integral sign. And you're going to have something to something. But let's start with 2x squared plus 5. My favorite equation for some reason. Always pops in my head. But 0 to 4. So you probably never realized that definite integrals were the area. But that's exactly what they are to the x-axis. But it's just a simple definite integral. So 0 to 4, and we're going to get 2/3 x. You know what? Let's just make this 0 to 4 of 3x squared plus 5 dx, which equals x cubed plus 5x. No c because we're definite here. You're going to plug in 4, you're going to get 64 plus 20, which equals 84. And on our graph of 3x squared plus 5, at 4 it equals 84, and the point would be 484. Now you're probably looking at this thinking, whoa, Chris, I still don't understand. Why don't I just do definite integrals? Why do we have to worry about area? Well, what happens if you have a graph like this? And you have y equals x plus 1. Here's 1. And it goes to the 1. And then you have x squared. And it goes up like this. And you're trying to figure out the area from 0 to whatever they meet at. Let's say, I believe they meet at, let's say x equals 1. Y equals x squared. At 1, they're going to meet at 1, and they meet at 0 as well. For what we want to find the area between 0 to 1 of x squared and between these two curves. As you can see, we're trying to find this area right here. So how do I start doing this? Well, really, if you think about it, if you look at y equals x, we're trying to find the area from y equals x, all this area right here. But then we're also trying to find, but then when we got to figure out how to figure out in between right here. So we need all this gone. So what we can do is, seeing as how x squared is right there, we can find the area of x squared, which will be that y area, and subtract it off. And we'll be left with this area. So the top, you got to always find the top line. That's what you're looking for in simple terms as to why that is, but you got to find the top line. And the top line is y equals x, so we're going to put x here. So we want to subtract off the bottom line's area, and we have it as x squared dx. And that's what the area is going to be for this. 0 to 1, x squared x. The reason why it's 0 to 1 is because that's where they intersect at. And we can't find the area. If we try to go farther than that, the area is just going to keep going and going and going. And x squared is going to be the top function after that. So you do that, and you're going to get 1/2 x squared minus 1/3 x cubed. Plug in 1, and you're going to get 1/2 minus 1/3 over here. And 1/2 minus 1/3 is 3/6 minus 2/6. We're going to get 1/6. and that's the area between those two curves. Now you're probably looking at this like, this is still pretty difficult. I don't understand why I want to do this and all this fun stuff. Well, what happens if I give you 3x squared right here and y equals x and y equals 3x squared? I have these two equations here and I want you to find the area between the two curves. And you're like, whoa. How do I know where I'm going to go to and where? Well, you got to make them equal each other. And if you do that, you're going to get 3x squared minus x equals 0. And then you got to make them equal to 0 and find where they meet x. Well, you can take an x out and you got 3x minus 1 equals 0. And you know they meet at 0 and 1/3. So you can do the same thing you did up here. 0 to 1/3. And you're going to have whatever the top line is. Now the top line, we have no idea what it is, so we're going to have to pick a number in between 1/3 and 0 to figure out what it is. So let's pick 1/6. 1/6 squared is equal to 1/36. 3 over 36 equals 1/13. I'm sorry, 12. 1 over 12. Y equals 1/6 is bigger than 1 over 12, so we know y equals x is going to be on top. So we're going to put x minus 3x squared. That's dx. And that'll equal, when we do our little thing, 1/2 x squared minus x cubed. And then you just do 1/3 to 0, and just plug in 1/3, and that's what your answer is going to be. And that's basically all about area. You can be doing it from the y-axis, and all you have to really do is find the inverse, which means you have to solve for x instead of y. I mean, you don't have to find the inverse. You gotta solve for x instead of y, and you're gonna be doing things from right to left. But it's not that hard. It's just from the y, and it's from a different perspective. But hopefully you understand what I've shown you here today on area. Good luck on your AP exam.